I'd like to share with you what I've learned, and I'm going to start with a general rule that says in order to accomplish a specific task like generating lift or generating thrust, the most efficient way to do that is to act gently upon the largest volume of air that you can. So the first thing is you have to generate lift from the wing, and the idea here is you want a high aspect ratio wing so that it acts upon a large amount of air and it acts gently. So the amount of time that the air is in contact with the wing is pretty small. That's related to the distance from the leading edge to the trailing edge. And you want to act on a lot of air, so your wingspan is quite large. In this case, the wing is from a Phoenix 2400. I would have used the fuselage also, but it was a little too narrow to easily accept the battery and the flight controller and all the other electronics. That same rule about acting gently upon as much air as you can applies to the propeller. So for efficiency, you want to swing a large propeller very slowly. The second important lesson that I've learned is to use lithium-ion batteries. There's a specific type of lithium-ion chemistry called NCR 18650GA, and it has 44% more energy for the same weight. I built this pack out of 24 cells in a 4 series 6 parallel configuration. So it's a 4 cell pack that has a capacity of 21,000 milliampere hours. It weighs 2.6 pounds. The plane, including the battery, has an all-up weight of about 5.9 pounds. And here's a picture of the plan form of the aircraft. Here's a shot of the fuselage. If you look carefully, you can see a little strip of LEDs on the left side. So here's some video of the launch. The third term from the bottom is fly time in minutes. And as soon as I launch it, it starts counting automatically, which is really impressive. I was anticipating it starting to count as soon as I arm the plane, but it's really nice to see that it's going to give us a nice accurate measurement. So these are little 8-second clips from times throughout the flight. I'm going to talk about the on-screen display and what each of the terms are. The first one is ground speed in miles an hour, altitude in feet, vertical speed indicator, number of GPS satellites that it's listening to, a pitch indicator, so 8 degrees of nose-up pitch, battery voltage, current, milliampere hours consumed so far, throttle setting, which it's automatically managing, flight time in minutes, and distance along the ground, and finally flight mode. The flight controller that I'm using is a Maytech F405. Originally I was using the default iNav software, but I found that for some reason it had serious difficulties trying to maintain altitude. I'm not sure if it was the barometer or if it was the GPS readings, but after I flashed it to use the Arduplane software, it was much more stable. Watch this editing. Watch this jump cut. Boom, nighttime. I'm really proud of that. I don't know why. I think it's a cool effect. Anyway, the flight controller F405, really nice board, built-in current sensor, voltmeter, built-in on-screen display, super user-friendly. At this point, I've hit 4 hours and 3.5 minutes, and I decide to bring it down. As I get close to the ground, you'll see the grass being lit by the LEDs, and you'll see the timer automatically stop shortly after landing. And once again, this did not happen because of arming. This happened automatically. There's the moment that I actually disarmed the airplane. The current reading there is 19,000 milliampere hours. Here's a shot of the airplane. I put the battery back on my charger and fully recharged it to see how much went back into it. And my charger said 16,500, which means I only used 78% of the battery's capacity.